The waiting times between a subway departure and the arrival of a passenger are uniformly distributed between 0 and 5 minutes. Find the probability that a randomly selected passenger has a waiting time between 1.5 and 4.5 minutes. So we want the probability that x is between 1.5 and 4.5. Since it's a uniform distribution, the distribution takes on the shape of a rectangle. X, probability of x, between 0 and 5 minutes. So we draw a rectangle. So the entire distribution between the lower limit of 0 and the upper limit of 5 is a rectangle. The probability of randomly selecting any single value within this distribution is 1/5. This 5, use the endpoints, the lower limit and endpoints. 5 minus 0. 0 is associated with this point right here. We can now draw a line straight up indicating 1.5 and 4.5. Those are probably not exact locations, but it's okay. And we shade this in. In order to find the probability in a continuous probability distribution, such as the uniform and the normal distributions, you need to find the area under the curve associated with the region that you're trying to find. So notice from here to here, this distance is 3. 4.5 minus 1.5 is 3. This height is 1/5. Since we're finding the area of a rectangle, we use the area of a rectangle formula. So it's base times height. 3 times 1/5, which is 3/5, which is 0.6000 if you round it to 4 decimal places. As a percentage, that would be 60%. Assume that adults have IQ scores that are normally distributed with a mean of mu equal 100 and a standard deviation sigma equal 15. Find the following. The probability that a randomly selected adult has an IQ greater than 105. So probability x is greater than 105. So there's two methods here that you could use. There's a z-score distribution, a z-distribution that lists areas to the left of z, or you can use the normal CDF function in your calculator. So I'll mostly be using the normal CDF function in my calculator for this. First thing we have to do, though, is we have to convert our random variable to a z-score. And the formula is x minus mu over sigma. This will give us 0.33. Z-scores are always rounded to 2 decimal places. Now we draw a picture of the z distribution, which is a normal distribution. So it takes on the shape of a bell curve with a mean of 0 and a standard deviation of 1. We don't need to draw in the standard deviation. But if we draw a line straight down at 0.33, so that's the z-score that represents our random variable x, and then we shade the portion that we want. Now, if you were going to use the table will give you the area to the left of z. So the area to the left of z from the table is 0.6293. So that's the area up to a z-score of 0.33. So using the table, we would have to we would have to subtract that number from 1 because the total area under the curve equals 1. So we're going to get 0.3707. If you have a graphing calculator, you can use what's called normal CDF. So for normal CDF, what you need is left boundary, right boundary. So we want the area from 0.33 to infinity, but we're going to write 999999, so 99,999. You could also use 1e99 to indicate 1 times 10 to the 99th power, which is actually bigger than this number. But using 99,999, you'll be fine. Then you need to indicate the mean of the distribution that you're working in. Then you need to indicate the standard deviation of the distribution that you're working within. So we'll go to our calculator. Second vars, normal CDF. Now some calculators you have to actually type it in the way I just wrote it, and then some are like this. So our lower limit is 0.33. Our upper limit we're going to use is 99999. The population standard deviation for the standard normal distribution is 0. And then the population mean is 0. Population standard deviation is 1. And then we're going to paste that on some of the older calculators. This is actually, or TI-84 that's not a silver edition. You'd actually type this in right here, normal CDF, 0.33, comma, 99,999, comma, 0, comma, 1. Hit enter, and there it is, 0.3707. So we get the same answer. So in future examples, I'll indicate the numbers that you get off of the z-score table. I won't show the exact looking up the numbers on the table, but I will indicate those values. But then I'll also show you how to do this on the graphing calculator. All right, same population mean and population standard deviation. We now need to find the probability that a randomly selected adult has an IQ between 83 and 117. So we want probability that X is between 83 and 117. We need to convert both of these to a z-score. So X minus mu over sigma, and we get negative 1.13. And then the z-score for 117, it's the same distance away but in the opposite direction, so we get positive 1.13. So now this is equivalent to the probability that z is between negative 1.13 and positive 1.13. Drawing a picture, in our standard normal distribution, we are going to be between here and here, negative 1.13 and positive 1.13. So we need the area of that region. Okay, for the z-score table, what you need to do is you need to find the area to the left of the larger value first. You need to find that area, then you need to subtract the area to the left of the smaller one. That'll give you what's in between. So the area to the left of 1.13 from the table is 0.8708, and the area to the left of negative 1.13 is 0.1292. The area in between is the difference between those two numbers. and that's 0.7416. So this will be our answer. So we're getting, by subtracting these two, we're actually getting this area in between, and that's the 0.7416. So remember, the table gives you the area to the left of Z. All right, on our calculator, we're going to do this. Normal, CDF, negative 1.13, comma 1.13, comma 0, comma 1. Okay, so second vars, normal CDF, negative 1.13 to positive 1.13, and then we're working with a mean of 0 and a standard deviation of 1. Paste that. We get 0.7415. Get a slightly different answer. Either one of these would be fine. The table has values that are all rounded. This calculator does not use rounded values. Then we want the probability that a randomly selected adult has an IQ less than 135. So probability X is less than 135. We need to convert the 135 to a z-score, which is 2.33. This is equivalent to the probability that z is less than 2.33. If we draw a picture of it, here's 0. 2.33 would be a little bit farther out. We want the area to the left. In this case, using the table, you're simply just going to use the number on the table associated with 2.33 because that area is going to give you the area to the left of 2.33. So using the number straight off the table, you will get 0.9901. Or in other words, 99.01% of randomly selected adults have an IQ less than 135. If you're going to use the calculator, you're going to do normal, CDF. The lower limit is negative infinity, but we're going to write negative 99,999. The upper limit is 2.33. We're working in a mean of 0 and a standard deviation of 1. So we go to our calculator. Normal CDF, negative 99,999 to 2.33, mean of 0, standard deviation of 1, paste, hit enter, 0.9901. So you usually do get the same answer. Sometimes you're off by 0.0001. But in this case, we got the exact same answer.